Hello, Asuka. Hi, Ankit. How are you guys? I hope you're doing well. Hi, Muskan. Hello, Vanshaj. Hi, Diokan. Good evening. So, guys, in today's session, we'll be discussing about the second chapter of your syllabus, that is acid, bases, and salts, which is again one of the most important chapter. Hello, Rumi. Hi, Shreyas. Hi, everyone. Okay, so let's first of all quickly have a recap of all the topics which are included in this chapter. So as the name of the chapter is acid, bases, and salts. So let's begin with the acids. We all know that the physical properties of acids include they are sour in taste, they give H plus ions in water. That means they release H plus ions when they are dissolved in water. They have corrosive nature and they conduct electricity in solution. So these are the few physical properties of your acids. Similarly, moving on to the physical properties of your bases, it includes they are bitter in taste. Also, they have soapy touch. They give OH minus ions, that is your hydroxyl ions in water, and they also conduct electricity in solution. So these are the basic physical properties of acids as well as your bases. Moving on to the chemical properties that includes the chemical reactions of acids and bases, let's first of all discuss about the chemical reactions of acids. So the chemical reaction of acids include reaction with the metal. We all know acids react with metal to form salt along with the release of hydrogen gas. Similarly, your acids react with metals and metal carbonates and metal hydrogen carbonates to form salt along with the release of carbon dioxide gas and water. Similarly, there is a reaction between acids and metal oxides, and the product of these reactions are salt along with the release of water. Now, moving on to the chemical reactions of bases, let's discuss about them. So, the chemical reactions of bases includes reaction with metals. We all know that the bases they react with metals to form salt along with the release of hydrogen gas, as was in the case of acids. Similarly, in case of acids, they react with metal oxides, whereas in case of bases, they react with non-metal oxides. So when bases react with non-metal oxides, they again form salts along with the formation of water. So these are the basic physical and chemical properties of acids as well as bases. And these are really very, very important because you can be asked questions from these topics in your exams. Moving on to the next part, that is the reaction of acids and bases to form salts. We all know that this reaction is known as neutralization reaction, and such reactions are generally exothermic in nature. That means they are followed with the release of heat. Now, in your syllabus, you have to study different kinds of salts, which includes common salt, that is NaCl, caustic soda, that is NaOH, washing soda, which is Na2CO3.10H2O, baking soda, which is NaHCO3, sodium hydrogen carbonate. Next is bleaching powder, which is calcium oxychloride, CaOCl2. And the last one is plaster of Paris, that is calcium sulfate dot half H2O, or we can say calcium sulfate hemihydrate. Now, in this part, we also have to study about water of crystallization, which is again one of the important topic of your syllabus because question can be asked generally from this part. So what is water of crystallization? Let's have a quick recap of it. The water molecules which form part of the structure of the crystals are basically known as water of crystallization. Now, moving on to the second thing, which is another part of your syllabus, which includes your indicators. We all know that indicators are such substances which helps us to detect whether the substance is acid or base. Now, we have three different types of indicators: natural indicators, synthetic indicators, and olfactory indicators. So we'll again have a look on this in a separate slide. Till then, let's discuss about the pH scale. We all know that we use generally to measure the pH, that means to measure the strength of acid or base, which includes how strong an acid or how strong a base is. So that is basically a scale known as pH scale, and it measures the hydrogen ion concentration of the solution. And the importance of pH in our day-to-day life includes in digestion. We all know that in our stomach, HCl is being released for the digestion of food. Now, for the digestion of foods, when excess of HCl is released, then it causes irritation and pain in the stomach. Sure, Dipali, we'll definitely discuss about water of crystallization again in the question. Just wait for a while. So when excess of HCl is being released in the stomach, it starts hurting up, it starts paining and causes irritation. And in that case, we have to consume a base, for example, baking soda, or we can also use milk of magnesia to neutralize the effect of the acid. Similarly, we all know that plants, they require a particular pH range. They grow in a particular optimum pH range. If the pH range changes from that, we have to add such substances to bring the pH to the normal range, which is around 5.5 to 7. Last is the ant bite. We all know when an ant stings us, when an ant bites us, then it releases methanoic acid, or we also call it as formic acid. In that case, we all know there is redness on the body and also there is itching. So to take care of that, so as a remedy, we use baking soda, or we can use a base that will give us relief from the pain. So this was about your indicators. Now, one of the smallest topic which is mentioned in your NCERT, exactly, nettle leaves are also there, which are occurring in the nature. Nettle leaves also release methanoic acid, and also we have a natural remedy for it, which is the dock plants. Formula of formic acid is your HCOOH. This is your formula of formic acid or your methanoic acid, Tushar. Okay, now moving on to the pH of your salts. This is also one of the important topic which is only introduced in your syllabus, which includes neutral salts, acidic salts, and your basic salts. Now, your neutral salts, the salts which are neutral in nature, sure, Mayur, we'll definitely do that. Just wait for a while. It's dock plants. So when a strong acid reacts with a strong base, then the salt formed is neutral in nature. Similarly, if the acid is strong and the base is weak, then the salt form would be acidic in nature, because we are using a strong acid. Similarly, when a weak acid reacts with a strong base, what is the formula of pH? Shailendra, you won't be asking about the formula of pH. That is not in your syllabus right now, so don't worry about it. CBSE won't ask you in your exams about that. So when a weak acid reacts with a strong base, then the salt form is basic in nature. So this was a brief review of all the topics which we have covered in this chapter. Moving on to the next part, that is the different types of question which used to come in your exam. That won't be dealt in this part, Shreyas. That you'll be studying in your higher grades. Don't worry about it right now. Okay, Tushar, universal indicator are basically mixture of various indicators which gives different range of colors in dipping into the different solutions. Okay, so you have two types of questions on the basis as per your curriculum from the CBSE. We have theory-based questions. So that includes, you can be asked in your exams, what are acids and bases? You can be asked about their physical properties. You can be asked about their chemical reactions. How do they react with metal oxides? How do they react with metals? How do they react with each other? The next part is detecting an acid or a base, which includes your indicator part. What is the full form of pH? Full form of pH is your power of hydrogen. Now, detecting an acid or a base, basically, it includes your indicator part, which could the question from this part can be asked in the exam in a manner like, what would be the color change when a particular indicator is being dipped in an acidic solution or in a basic solution? Moving on to the next part, that is a common reaction of acids and bases. I have already just discussed about this with you. Next is importance of pH in everyday life, which includes your importance in soil, importance for your indigestion, and also we have covered one which is your ant bite. Sorry. Now, the next is salts and chemicals made from common salts, which includes all your salts, your NaCl, your caustic soda, sodium washing soda, baking soda, plaster of Paris, all of them. Exactly, in tooth also, that could be asked as an application. Last is your water of crystallization, which includes the water molecules which are present, which form the part of the crystal structure. As I have already told you, in some cases, for example, if we say we are writing down the formula of copper sulfate, then we say CuSO4.5H2O. Then this 5H2O is basically, Jyotsna, brine is a saturated solution of your sodium chloride. So your copper sulfate, the formula of your hydrated copper sulfate is CuSO4.5H2O. This 5H2O is basically your water of crystallization, which is present as a part of the structure of the crystal. When we heat it up, then these water molecules, they evaporate and the color is the compound loses its color. Generally, the color of this copper sulfate solution is blue. The crystals have a color blue, but when we heat it up, then the color vanishes and it becomes white. Okay. Now the next part is your practical based question. So after your theory based question, you would be asked some questions from the practical, and in your syllabus you have two practicals from this chapter. The first one is pH of the following samples using pH paper or universal indicator. Dilute HCl, dilute ethanoic acid. Mayur, for the schedule, you can simply subscribe to the meditation channel and click to the bell icon. You'll be notified whenever the sessions are going on. Exactly, Abdul. We'll discuss that. Just wait for a while. So your first practical includes pH of the following samples using pH paper universal indicator, which includes your dilute HCl, dilute ethanoic acid, or we call it as acetic acid, dilute NaOH, lemon juice, water, and dilute hydrogen carbonate solution. So you can be asked about the pH of these solutions. Next is the properties of acids and bases, that is your HCl and NaOH, on the basis of their reaction with. Hold on, Ambergini, we'll see to it soon. So HCl and NaOH on the basis of their reaction with litmus solution, solid sodium carbonate, and zinc metal. So you can be asked about their reaction with these. So these are the few important topics from which you can be asked questions in your board exams. Now, moving on to the next part, formula of ethanoic acid is CH3COOH. CH3COOH is your ethanoic acid. Okay, now, okay, Deepak, you're asking about dilute. Vikas, hold on, just wait for a while. Just wait for a while. Now, let's see what happens when we add water. We all know that it is advised to always add acid to water. We should never add water to acid because the reaction is highly exothermic. For ethanol, it's CH3CH2OH. So your water should never be added to your acid, but we should always add acid to water because the reaction is highly exothermic, and it can even cause severe burns and breaking of the glassware. So that's why, and when this acid or a base is added into water, when they're mixed up with water, then their concentration decreases, and that at that time we say they have become dilute. We'll discuss that, Aman. Just wait for a while. Now on this page, you can see there are important reactions from this particular chapter. So you have to go through these reactions. When sodium hydroxide is reacting with zinc, then there is formation of sodium zincate along with the release of hydrogen gas. Similarly, the reaction of sodium carbonate with HCl, sodium hydrogen carbonate with HCl leads to the formation of salt, water, and carbon dioxide. One should, if you can, then you should learn because there are only 6 chemicals, so it's better you should learn. The next is your reaction of calcium hydroxide with your carbon dioxide, which leads to the formation of your calcium carbonate along with the release of water. And also calcium carbonate reacts again with the excess of carbon dioxide and water to form your calcium hydrogen CaHCO3, right? And this is generally soluble in water. Now, discussing about your NaHCO3, when it's heated, then it leads to the formation of Na2CO3, sodium carbonate, along with the formation of water and carbon dioxide. The last is your sodium hydrogen carbonate. When it reacts with in acidic medium, it produces carbon dioxide along with the release of water and formation of a sodium salt of acid. So these are few of the important reactions from your chapter. Now moving on to the different types of salts, how they are prepared and their uses. This is one of the most important part of your syllabus, which you should go through thoroughly. You can be asked question from this part, and that is for sure. Mridula, acid would not be neutral. If it would have been neutral, then we would not have called it an acid. POP is plaster of Paris, Aldous. We'll discuss that. Now, see, the first one is common salt, and it is prepared by the reaction of sodium hydroxide with hydrochloric acid to form sodium chloride along with the release of water. And on the right side, you're given the uses. No, Palak, you cannot download these slides. You have to only watch the videos for this. And you have to note it down on your own. On the right side, you're given the uses of the particular salt. This is a kind of a table arrangement, tabular form. All the salts, their preparation and uses are given in a tabular form so that it would help you out to revise them together. The next is your sodium hydroxide, which is also known as your caustic soda, and the reaction taking place is NaCl is reacting with water, electricity is passed through it to form NaOH along with the release of your chlorine gas and hydrogen gas. Okay, Mridula, if a salt is reacting with, if the salt is of strong acid and a strong base, then the salt would be neutral. Diluted and concentrated, diluted solutions are those in which water has been mixed in the acid or base. Yes, Aldous, salt can be neutral. So sodium hydroxide is used in making dyes, bleaches, manufacturing of paper, making soaps and detergents. So these are various uses of, we'll discuss that, Aman, just wait for a while. The next is your washing soda, which is Na2CO3.10H2O. Here again, this 10H2O is basically your water of crystallization, and this is prepared by reacting sodium carbonate with water to give washing soda. And we all know that this sodium carbonate, Na2CO3, is simply known as your soda ash. And these are the various uses of this sodium carbonate dot decahydrate. Next is baking soda, which is NaHCO3, which is prepared by the reaction of ammonia along with sodium chloride and water and carbon dioxide to form ammonium chloride and NaHCO3, which has various uses, like it acts as an antacid, it is used in fire extinguisher, it is also used for making baking powder. No, salt can never be always neutral. It can be acidic as well as basic, Prabhakar. It can be neutral, acidic, or basic. Now, discussing about your bleaching powder, which has a formula CaOCl2, which is also known as your calcium oxychloride. It is prepared by the reaction between calcium hydroxide along with the chlorine gas. Aldous dilute means water has been added to the solution, either acid or a base, which forms CaOCl2 along with water. Antacids are those, see, anti-acids, which means they are basically working opposite of acid. Now, which it has also different applications. Similarly, we have plaster of Paris, which is prepared from gypsum. This is your CaSO4.2H2O is your gypsum. And when you heat it up, then 1.5 molecule of water is removed, which leads to the formation of CaSO4.5H2O, which is calcium sulfate hemihydrate. And it is used for various purposes like fireproofing material, making toys, decorative items, idols for worship, making designs on the ceilings of house, and also for your plasters. So this is a table which is including all the preparation and uses of the salts which are included in your syllabus, which is one of the most important part. Moving on to the next part, that is your different indicators and the color change. So here, the first three indicators are your natural indicators, which includes your litmus, your turmeric, and China rose. Exactly, Josna. Deepak, that is the formula of POP. Now, the acids, they turn blue litmus to red, and bases turn red litmus to blue. Exactly, it is possible, Deepak. Correct, Radhe. Similarly, turmeric, when it's put into acid, then no change takes place, whereas when it is put into base, it comes in contact with the base, the color changes from yellow to red. That is not in the part of your syllabus, Tanu. Don't go for it. Don't worry. CBSE won't be asking you about the preparation of gypsum. Next is your China rose. It turns dark pink in acidic solutions, whereas turns green in your basic solutions. No, exactly, Madiha. I'll be coming to olfactory indicators. So the next two are your synthetic indicators, which includes your methyl orange and phenolphthalein. We all know that methyl orange, they turn from orange to red in acidic solution and orange to yellow in your basic solution. Similarly, phenolphthalein, it does not have any color change in acids, whereas the color change from colorless to pink in case of basic solutions. The last two are your olfactory indicators. Olfactory indicators are those where there is change in smell. Olfactory indicators are those where there is change in smell. In this cases, there is no change in the color. So onion is one of your olfactory indicators, and the smell exists even when it is kept into the solutions of your acids. And the next is your bases. When onions are dipped in your bases, then no smell comes. That means smell vanishes. Similarly, exactly, Edu, that is also correct. Similarly, we have vanilla. Vanilla smell exists when we put it into your acidic solutions, whereas when it is put into the basic solutions, then the smell vanishes, no smell comes. So this is your table for your different indicators and their color change. No, Sujata, you can take the screenshot or you can note it down over somewhere in your notebook. What is antacid? Antacids are basically your bases, or you can also say alkali solutions, which basically give you relief from the pain caused by an acid. So now, will the change in different indicators? Exactly, Palak, you can be asked about the change in the different colors or your smell of the indicators in your exams. That is why this is included in the table. Moving on to the next part, that is your last year board questions from the theory part. So in your last year board, there was a question of 3 marks. That is, 2 ml of sodium hydroxide solution is added to a few pieces of granulated zinc metal. That is a reaction between your NaOH and your zinc metal. We have already gone through this reaction in the previous slide. Isha, that is already given in the table. You can see to it. No, Radhe, that is not, because it loses its properties. When the contents are warmed, a gas evolves which is bubbled through a soap solution before testing. So which would be the gas? Tell me the name of the gas. What would be the name of the gas? Exactly, that is hydrogen, correct. So name the gas which will be evolved when the same metal reacts with dilute solution of strong acid. We all know that when again the same metal, that is zinc, is reacting with the dilute solution of an acid, then definitely again hydrogen gas will be evolved along with the formation of salt. And you can test for hydrogen gas by bringing a burning candle near it, by bringing the gas, the gas which is being released, by bringing a burning candle near it, it will burn with a popping sound. Aldous, that is part of your metals and non-metals. We'll be discussing that in the next session. Exactly. So this would be a test for your hydrogen gas. Now, the pH of salt used to make tasty and crispy pakoras is 14. Identify the salt and write a chemical reaction equation for its formation and list 2 uses. So what would be the name of the salt? We have just discussed about this. What would be the name of the salt? Exactly, correct, Vintage. It's baking soda, and the uses are already given, and the reaction is already given for its preparation in the table. You can go through that. Now, moving on to the next part, that is the sample paper question. The sample paper issued by CBSE for this year includes these questions. Identify the compound of calcium which is used for plastering of fractured bones. What is the name of this? What is the name of this? Sure, Sanjay. Fine. What would be the name of the salt of calcium which is used? Exactly, it's POP, or we can call it as plaster of Paris, or calcium sulfate hemihydrate. You can write down the chemical reaction to show its preparation. That's already given in this table. This is the reaction for its preparation. You can write it down from here. Exactly. Now moving on to the next part, that is sweet tooth decay may lead to tooth decay. Sweet tooth may lead to tooth decay. Explain why. What is the role of toothpaste in preventing cavities? We all know that the tooth enamel is made up of calcium phosphate, which is one of the hardest substance known in our body. Now, when we consume food, the bacteria then it tries to break down the food, and in doing so, it releases acid. So that acid can be harmful. It can decompose that calcium phosphate, the tooth enamel, and cause cavities. So to neutralize that, we use basically the toothpaste, which are generally your bases. Exactly, toothpaste is a base. So this was about your theory-based question. In last year, you were not asked about any question from your practical base from this chapter, but in this year's sample paper issued by CBSE, you have been asked a practical-based question from this chapter. When few drops of phenolphthalein are added to a dilute solution of sodium hydroxide, a pink color is produced. What will be the color of the final mixture when excess of HCl is added to it? So could anyone tell me what would be the color of the final mixture of the final mixture when HCl would be added to it? Exactly, it would be colorless because we all know that phenolphthalein, when comes in contact with the acid, when it's put into the acidic solution, the color is colorless. It's colorless. Fine, that's really great. Moving on to the next part, that is your important points to remember while preparing this chapter. So guys, while preparing this chapter for your boarding, from your board point of view, remember the color changes for different indicators in acids and bases. You can be asked questions from there. What would be the colors when certain indicators are dipped into your acidic or basic solutions? This is one of the most important part. The next important part is don't forget to learn the preparation and uses of different salts. We have already given you a table summarizing all the salts along with the preparation and the uses. So revise that continuously so that it would be easy for you to revise it again. Next is learn different acids and bases present in some daily use substances. For example, your vinegar and your tomatoes, your various other things, your milk, curd, what are the different acids and bases present in those? Go through them, which is there is a table given in your NCRT, so don't forget to revise it. The next is remember the formula of the hydrated salts and their colors. So hardly there are two salts in your syllabus, that is your sodium carbonate, your washing soda, and your copper sulfate. So remember their colors along with their formula, including your water of crystallization. And the last part is your baking soda. Okay, I have already taught you baking soda. It is included in the table. If you are asking about baking powder, then baking powder is a mixture of your baking soda along with the mild edible acid, which is your tartaric acid. Okay, so last is while writing the chemical equations, do take care of the state of the compounds and the chemical reaction conditions, whether it is solid, liquid, gas, or your aqueous. Mention the state of the reactants and the products while writing a chemical reaction. Also make sure that the reaction is balanced. That is your duty to make sure that the reaction is balanced. And also mention the reaction conditions. For example, if heat is released or it is being absorbed, or various temperature or pressure conditions required for a particular reaction to take place. Exactly. Now, with this, we'll be ending the session. And to know how Merit Nation can boost your preparation for science with Power Pack Premium courses, go through this link and send us your details. And also, exactly, Deepak, we have to mention the catalyst as well. And also, to get MN Top 100 question, there is a link provided below the video. You can go through that link, provide us your details, and we'll send you the top 100 questions from this particular chapter. So with this, we'll be ending the session, and I hope you all enjoyed the session and it was quite informative and helpful to you for your preparation. For more such sessions, please subscribe to the channel and click on the bell icon. And if you like the video, then you can click on the like button. Thanks a lot. With this, we would be ending the session.